Okay, so in the previous video we reviewed our basic index laws, which we should have learnt previous to now. And in this video we're going to be looking at negative indices. Now I think negative indices should be something you've met previously as well, but possibly haven't done as much work with negative indices, and it is an area that students tend to make mistakes with, so we want to just focus individually on negative indices here. Okay, so let's just have a look at the following examples to sort of establish what's happening here. So if we have a to the power of 5 divided by a to the power of 3, well, we know that's a times a times a times a 5 times on the numerator and a times a times a 3 times on the denominator. So we know we can simplify that fraction by dividing the numerator and the denominator by a once, twice, and 3 times until we're just left with 1 on the denominator and we just have a squared left on the numerator. We also know we can get to that result because if we use our index law, a to the power of 5 divided by a cubed is a to the power of 5 minus 3, which is a squared. Okay, so we're comfortable with that. If we have a look at example 2, we've got a to the power of 5 divided by a to the power of 5, which is a times a times a times a times a on the numerator and a times a times a times a times a on the denominator. So we can divide numerator and denominator by a once, twice, 3 times, 4 times, 5 times, and we're just left with 1 over 1, which is 1. Again, we can use our index laws, which tell us that a to the power of 5 divided by a to the power of 5 is a to the power of 5 minus 5, which is a to the power of 0. And we looked at this in the previous video, and that's where we get the result that a to the power of 0 must equal 1. Okay. Now, if we think about the third example here, where we've got a to the power of 5 divided by a to the power of 7. Okay, so again, we can simplify this fraction, divide the numerator and denominator by a once, twice, 3 times, 4 times, 5 times. And now we can't simplify any further because we've only got 1 left on the numerator, but we've got a squared on the denominator. So this is 1 over a squared. Okay, if we think about this using our index law for division, like we have with all the previous examples, if we have a to the power of 5 over a to the power of 7, we do a to the power of 5 minus 7, which is a to the power of negative 2. And once again, like the example 2, we have done this in 2 different ways to find 2 slightly different results, and therefore, what we learn here is that a to the power of negative 2 is the same as 1 on a squared. Okay, and so here we've got negative powers. A to the power of negative 2 means 1 on a squared. If it was a to the power of negative 3, it would be 1 on a cubed. If it was a to the power of negative 10, it would be 1 on a to the power of 10. Okay, so we can also consider this simplification in 2 different ways. So if we have a look at a to the power of 0 divided by a to the power of n, okay, well that's a to the power of 0 is 1 divided by a to the power of n, so we can write that as 1 on a to the n. Or we can use our index laws for dividing, which means it's a to the power of 0 minus n, and so it's a to the power of negative n. And once again, these 2 things have to therefore be the same. So a to the power of negative n is the same as 1 over a to the power of n. So for example, if we had x to the power of negative 4, that is 1 over x to the power of positive 4. The negative has got nothing to do with multiplying by a negative. It's got nothing to do with making the value of the thing negative. It's all about taking the reciprocal. Okay, instead of having x as the base, you now have 1 on x as the base. Okay, so this is essentially telling you I'm really x to the power of 4, but I'm on the wrong side of the fraction. Instead of being on the numerator, I should be x to the power of positive 4 on the denominator. Okay, example B, 2x to the power of negative 3. Again, this is where we need to be careful about our order of operations. Remember, this is 2 times x to the negative 3. There is no negative power associated with the 2 whatsoever, so it doesn't go anywhere. This is 2 times x to the power of negative 3 is 1 on x cubed. Now 2 is just 2 over 1, and so what we have here is 2 on x cubed. So the 2 doesn't go to the new denominator, it's not raised to a negative power. It is just 2, it's going to stay on the numerator. Alright, if we have y to the power of negative 2 divided by 5. Now again, let's be clear about what's happening here. Dividing something by 5 is the same as multiplying it by a fifth. This is just a fifth times y to the negative 2. Okay? It's 1/5. And so y to the negative 2 is 1 over y to the positive 2. And so they're multiplying those things back together. We've got 1 times 1 on the numerator and 5 times y squared on the denominator. So the 5 was on the denominator to start with, it stays on the denominator. Okay, here 2 was on the numerator to start with, it stays in the numerator. Alright, example 2, evaluate each of the following. So 5 to the power of negative 3. Well, that's the same as 1 over 5 to the power of positive 3. 5 cubed is 125, so it's 1 on 125. If we have 6,000 times 10 to the power of negative 3, so that's 6,000 times 1 over 10 cubed. Now 10 cubed is 10 times 10 times 10, and so that is 1,000. Now, if we've got 6,000 times 1 on 1,000, we've really got 6,000 on 1,000. And again, we can divide by 10 again, and divide by 10 again to find that we just have 6. Alright, if we have 2 to the power of negative 2 plus 6 to the power of negative 2, adding, there's no index laws for those, so you need to just focus on evaluating each of these things separately and then adding them together. So 2 to the power of negative 2 means 1 on 2 squared. 6 to the power of negative 2 means 1 on 6 squared. So 1 on 2 squared is 1 on 4. 1 on 6 squared is 1 on 36. To add these together, we're going to need a common denominator. That common denominator is 36. So 4, we need to multiply that by 9. So 1/4 is the same as 9/36 plus 1/36, which means we get 10/36, but that's not in simplest form. 2 is a common factor, so it's 5/18. Okay, let's have a think about these examples. If we had 1 divided by x to the power of negative 2. I'm going to write this out as 1 divided by x to the power of negative 2, which is 1 divided by x to the power of negative 2 means 1 on x squared. Now we know if we divide by a fraction, it is the same as multiplying by the reciprocal of that fraction. So we've got 1 times x squared over 1, and so that's just 1 times x squared, which is just going to be x squared. We can do that for a to the negative n as well. It's exactly the same process. 1 divided by a to the power of negative n. Well, a to the power of negative n means 1 over a to the power of positive n. And dividing by a fraction, we multiply by the reciprocal of that fraction. And so we just have 1 times a to the n over 1. A to the n over 1 is just a to the n. 1 times a to the n is just a to the n. So if we have the negative power, negative exponent on the denominator, then we end up with the positive exponent on the numerator. So 1 divided by a to the negative n is a to the power of positive n. Okay? So as I said, the negative is really just telling you I'm on the wrong side of the fraction. So a to the power of negative n means I should be a to the power of positive n, but I shouldn't be, a to the power of negative n is a to the power of negative n on 1. I shouldn't be on the numerator, I should be on the denominator with a positive power. Okay? If I've got a negative power on the denominator, all the negative's doing is telling you I'm on the wrong side of the fraction. Okay? I should be a to the power of positive n on the other side of the fraction. Okay? So the negative, as I said, nothing to do with multiplying by a negative. It's all about the idea of taking the reciprocal. Remember, taking the reciprocal is, if you've got p over q, the reciprocal of p over q is q over p. So it's about flipping fractions. Alright, so using this idea, if we have 1 over x to the negative 3, that's just going to be x to the positive 3. Okay? I should be x cubed on the other side of the fraction, so I should go from the bottom to the top. If we have 2 divided by x to the power of negative 5, again, there's nothing going on with the 2 there, it's going to stay on the numerator, but the x to the negative 5, I should be x to the positive 5 up on the numerator. Okay? So I should be 2x to the positive 5. Over 1, yes, but that's over 1 is meaningless. Alright, again, let's not freak out about this here, it's a bit confusing, but this is just 3/5. Let's just separate that out if we need to. That's 3/5 times 1 on y to the negative 2. That's what's happening there. This is y to the positive 2, so we've got 3/5 times y to the positive 2. You can put that back together as a single fraction. It's 3y squared on 5. You should be able to get straight here though. It's really just about that. I'm actually y squared and I should be on the numerator. Okay, so I get 3 times y squared divided by 5. Right, evaluate each of the following. So again, actually work it out to be a single numerical value. So we've got 1 over 4 to the power of negative 3. So that's the same as 4 to the power of positive 3. And 4 cubed is 64. Alright, 2 to the negative 5 is 1 over 2 to the power of 5. And then 1 over 4 to the negative 1, that's 4 to the positive 1 over 1. Okay, so 1 over 2 to the 5 is 32. 4 to the 1 is just 4. So we've got 4 on 32, which is 1/8. Okay, in both of these instances, we've got negative powers on the denominator, so they should be positive powers on the numerator. So this should be 2 times 5 squared minus, this should be 3 times 2 to the power of 4. Okay, so that's 2 times 5 squared is 25, minus 3 times 2 to the power of 4 is 16. 2 times 25 is 50. 3 times 16 is 48. So we've got 50 minus 48, and so that just equals 2. Just one step at a time. Try not to do too much at once. Just take your time, do one thing at a time until you get to where you need to go. Alright, then let's think about if we have negative powers of a fraction. Okay, so we could think about our index law. We know that we can apply this power to both the numerator and the denominator. So 4/5 all to the power of negative 1 is the same as 4 to the negative 1 over 5 to the negative 1. Now 4 to the power of negative 1 means I should really be 4 to the power of positive 1, but I shouldn't be on the numerator, I should be on the denominator. And similarly, 5 to the negative 1 on the denominator means I should be 5 to the power of positive 1 up on the numerator. So actually, we've just got 5 over 4. Let's do the other examples and then let's generalise what we're seeing happening. So 2/3 to the power of negative 2, so that's 2 to the negative 2 over 3 to the negative 2. Again, the negative powers mean they should be on the opposite side of the fraction. So it should be 3 to the positive 2 on the numerator and 2 to the positive 2 on the denominator. Now 3 squared is, well, we could write this in a couple of different ways. We could write that as 3 on 2 all squared. That's the same thing. Okay, just to be clear. It's not a step I would take, but I want to be clear about what's actually happening in this process. And so this is turns out to be 9 on 4. Alright, again, if we generalise that a bit further, a over b to the power of negative n, well that's a to the negative n over b to the negative n, which means actually it should be b to the positive n on the numerator and a to the positive n on the denominator. And so we could write that, if we want, as we don't need to, it's not more simple, but we could write it as b over a all to the positive n. So that's the key. Again, the negative tells you you need to take the reciprocal. So it's actually the same. If we have a to the power of negative n, we can think about that as being a over 1 to the power of negative n. And so it's telling us to take the reciprocal of the base and make the power positive. So we get 1 to the n, which is just 1 over a to the n. Okay. If we do it the other way around, if we have 1 on a to the negative n, okay, again, we can think about the need to take the reciprocal of the base. 1 on a to the negative n is actually just the same as 1 on a all to the negative n. Again, we take the reciprocal of the base, a over 1 to the power of positive n, and so we just get a to the n. So they're the two we've already looked at. This same idea, the negative power tells you to take the reciprocal of the base. So this is the same, a over b to the power of negative n is the same as b over a to the power of positive n. We don't need to go through these 2 or 3 steps to get there, we can just get straight there. Express each of the following with positive indices in example 5. So if we have y over 5 to the power of negative 2, that's the same as 5 over y to the power of positive 2, which we could expand out as 5 squared, which is 25 over y squared. Okay, 1 over 2x to the power of negative 3. Again, we can write that as 2x over 1 to the power of positive 3, which is just 2x. the power of positive 3. 2 cubed is 8 times x cubed. Example 6, evaluate each of the following. A quarter to the power of negative 3 is the same as 4 over 1 to the power of positive 3, which is just 4 to the power of 3, which is 64. Negative 5/7 to the power of negative 2. Okay, so this negative means that the number's actually negative, whereas this negative in the power means that we need to take the reciprocal. The reciprocal of negative 5/7 is negative 7/5. Okay, it doesn't change the negative. You can think about, remember, negative 5/7 is the same as negative 5 on 7, or it's the same as 5 on negative 7. If you take the reciprocal of that, you get 7 on negative 5. You take the reciprocal of that, you get negative 7 on 5. Regardless, both of those things are just negative 7/5. Okay, so the reciprocal, it's still going to be negative. We're just flipping the numerator and denominator around. Okay, so we've got negative 7/5 to the power of positive 2. We've taken the reciprocal, that was the negative power. And now we can square. So perhaps it is easier to think about assigning this negative to one of the numerator or denominator, or you could think about it as being negative 1 times 7/5 if you want. That's exactly what it is. Negative 1 squared is positive 1. So you have positive 1 times 7 squared, which is 49, over 5 squared, which is 25. So we just have 49 on 25. You would get the same result if you thought of this as being negative 7 over 5. So negative 7 squared is positive 49, 5 squared is positive 25. So however you want to think about it, you end up with the same result. Okay, so summarising our index laws for negative indices, a to the negative n, the negative tells you you're on the wrong side of the fraction, you should be on the bottom, and you should be a to the positive n. Here, the negative in the denominator is telling you you're on the wrong side of the fraction, you should be in the numerator, and you should be positive. So you end up being a to the n over 1, which is just a to the n. The negative power here tells you you should take the reciprocal of the base, so it's going to a over b to the power of negative n is b over a to the power of positive n, and if we need to, or if it's helpful, we can then expand that out to b to the n on a to the n. Okay, so the key thing is that these negative indices are just more index laws to add to our list, and they work together in conjunction with all the index laws that we already know. So we can deal with similar problems to what we looked at in the last video, where there's also negative indices. I find that students often get a bit tangled up worrying about the negative indices too early on. Generally speaking, I would say it's always best to worry about the negative indices right at the end, because what you might find is after you've done all your other simplification using your other index laws, you might not actually have any negative indices still at the end, left at the end. So I would just focus on use all my other index laws, and then once I get to my simplified answer, if it has any negative powers, then I need to make sure that I rewrite my answer with positive indices, because the question tells me to express my answer with positive indices. But that's the last thing I would worry about in the process. So I'm going to continue the same process I looked at in the last video. I like to do brackets first, I then like to multiply things together first, and then I like to focus on dividing. Okay, so no brackets in this first one, let's just deal with the second one. So that's 2x cubed y to the negative 1. I'm not worried about the negative power, I'll worry about that after I've combined everything together. And then we've got 5 times x to the negative 1 squared, so we know we multiply powers together in this instance. So negative 1 times 2 is negative 2, so it's x to the negative 2. And y, now that's y to the 1, and so 1 times 2 is 2. Okay, now we can multiply things together. So again, let's just focus on multiplying the numbers together, multiplying the x terms together, and multiplying the y terms together. So 2 times 5 is 10. X cubed times x to the negative 2. When we're multiplying, we add powers together. 3 plus negative 2 is 3 minus 2, which is 1. So we've just got x to the 1. And then y to the negative 1 times y squared. Again, when we multiply with the same base, we add powers. Negative 1 plus 2 is also positive 1. So we've just got 10xy. So you see there's no point in worrying about these negative powers at the beginning, because actually by the time I just multiply the things together, I don't have any negative powers left at the end anyway. So I actually haven't used my negative powers, my index laws for negative powers at all here. They weren't necessary in the end. Again, you could muck around with flipping those things onto the other side of the fraction, but let's worry about it later. Let's just focus on all the other index laws first. So again, let's focus on dividing the numbers, dividing the a terms, and dividing the b terms. Okay, So 4 divided by 8 is 1/2. A to the power of negative 3 divided by a to the power of negative 5. When we're dividing with the same base, we subtract. Negative 3 minus negative 5 is negative 3 plus 5, which is positive 2. And then b to the 4 divided by b to the 1, subtracting those powers, is b cubed. So we could leave that written as half b cubed, or we could put it all back together as one fraction, and we've got half a squared b cubed, or we could put it all back as one fraction. We've got a squared b cubed on the numerator and 2 on the denominator. So we can write it either as either of these. Both are perfectly fine. They both have positive indices. Alright, example C. Again, let's focus on the brackets first. So it's a to the 1 to the power of negative 4, so 1 times negative 4 is negative 4, so we've got 4a to the negative 4, and then b cubed, and then to the power of negative 4, we multiply those powers together, so that's b to the negative 12. Multiplied by, let's leave the second one as it is, 3a squared b to the 7. Alright, so let's multiply numbers together. 4 times 3 is 12. A to the negative 4 times a to the power of 2. We add powers. Negative 4 plus 2 is negative 2. B to the negative 12 times b to the 7. We add powers when we're multiplying. Negative 12 plus 7 is negative 5. Okay, so this is 12 times, that's 1 on a squared, that's 1 on b to the power of 5. Okay, again, you can skip this step. I would probably go straight to this next step. Putting that all together, I've just got 12 on the numerator, and I've got a squared b to the 5 on the denominator. I would go straight from there to there. The a to the negative 2 should really be a squared on the denominator. B to the negative 5 should be b to the 5 on the denominator. 12 stays exactly where it is on the numerator. Okay, D. So, again, let's focus on numbers, x terms, y terms. Okay, so 15 divided by 3 is 5. X to the negative 11 divided by negative 4, we subtract powers when we're dividing. Negative 11 minus negative 4 is negative 11 plus 4, so that is negative 7. Y squared divided by y cubed, we subtract powers. 2 minus 3 is negative 1. So again, we've got two negative powers. Both of those things should go on the denominator. So 5 stays on the numerator. X to the 7 goes to the denominator, y to the 1, so just y goes to the denominator. If you need, you can write out this interim step. You've got 5 over 1 times 1 over x to the 7 times 1 over y, and then put it all together. But hopefully you can get straight from there to there relatively efficiently and accurately. Okay, example E, the last one. Let's focus first of all on the brackets, then let's focus on the multiplying, and then let's focus on the dividing and making sure our final answer has all positive indices. Okay, so let's square everything in this first bracket. So m to the 4 and then squared is m to the 8. N to the negative 2 and then squared, negative 2 times 2 is n to the negative 4. R cubed and then squared, 3 times 2 is 6, so it's r to the 6. Multiplied by r cubed to the power of negative 2, so that's r to the negative 6. M to the negative 3 times to the power of negative 2, so multiplying negative 3 times negative 2 is positive 6. And n squared to the power of negative 2, multiplying 2 times negative 2 is n to the negative 4. Okay, again, lots of negative powers. I can focus on shifting them around, but personally I don't worry about them until the end. Let's just focus on multiplying across the fractions. So on the numerator we've got m to the 8, n to the negative 4, r to the negative 6. And on the denominator I'll write them in the same order. I've got m to the 6, n to the negative 4, r to the positive 6. Okay, let's focus separately on m terms, n terms, and r terms. Okay, so m to the 8 divided by m to the 6, we subtract powers, that's m squared. N to the negative 4 divided by n to the negative 4. Negative 4 minus minus 4 is negative 4 plus 4, that's 0, n to the 0. And then r to the negative 6 divided by r to the positive 6, we subtract powers. Negative 6 minus 6 is negative 12. Okay, n to the 0 is just 1, so that's m squared over 1 times 1 over r to the 12. Okay, so 1 is just 1 over 1. So all we have on the numerator there is m squared, and all we have on the denominator is r to the 12th. And again, you shouldn't really need this line, you should be able to get straight from here to here, but just to be clear about what's happening. Okay, so again, some practice for you to do from exercise 3F, so focusing on negative indices and then incorporating those together with all of our other index laws.